Hello everyone, my name is Sethi. I hope you all are staying healthy. Today we are going to talk about differentiation and its economic application with MCQ, especially for UGC Net in economics. Differentiation is a process of finding rate of change of one variable with respect to another. Differentiation is a process of finding rate of change of one variable with respect to another. For example, y is a dependent variable. Here we assume y is demand. X is independent variable and we assume X is price. As we know, when price change, demand also change. Differentiation is a process to finding rate at which y change with respect to change in x. In order to find this rate, we will differentiate y with respect to x. So we can say that differentiation is a process of finding rate of change of one variable with respect to another. Sometimes we are confused between differentiation and derivative. Differentiation is a process of finding derivative. Now we will see some basic formula. Y equal to x to the power n, we have to differentiate y with respect to x. This is a formula nx to the power n minus 1. That means first of all we will bring this power down, then minus 1 from original power. For example, y equal to x to the power 7, we have to differentiate y with respect to x. First of all, we will bring this power, means this 7 down, then minus 1 from original power. It will become equal to 7x to the power 6. Second thing, derivative of constant is always equal to 0. Here k is constant, that's why derivative of constant is equal to 0. Here 5 is constant, that's why derivative of constant is equal to 0. Obviously, if there is no x, we have to differentiate y with respect to x. If there is no x, obviously derivative of constant will become equal to 0. How to differentiate when constant and variable both are together? Here k constant, x variable, both are together. In such a case, we will keep a constant out and differentiate x variable. So this is formula to differentiate y with respect to x. This power will come down and minus 1 from original power. We have already discussed this formula. So in this question, constant 8 and variable x both are together. So we will keep this constant out and differentiate this variable. This power will come down and will minus from original power. 3 minus 1 become equal to 2. So it will become equal to 3x square. When we multiply, our answer will 24x square. This will be our final answer. How to differentiate when root is given? So here you can see we have a root, we have to differentiate y with respect to x. We can write root as a 1 by 2 and now we simply differentiate y with respect to x. This power will come down and minus 1 from original power, it will become equal to minus 1 by 2. So this power will come below. Again we put root, so this will be called our final answer. Two more things also you need to remember in case of differentiation. Differentiation of log x will always equal to 1 by x. This is exponential function. We have already discussed about exponential function where constant is base and variable is in power. Here e is a constant and x is variable which is in power. And derivative of e to the power x with respect to x will always written as the same, e to the power x. Now we will see summation rule of differentiation. According to summation rule, if y is connected with so many terms, then separately differentiate each term and apply given sign. If plus sign given, then apply plus sign. If minus sign given, then apply minus sign. We will clearly understand with the help of one example. Here you can see y is connected with so many terms. Y is connected with this term, this term, this term and this term also. So we will separately differentiate each term. First of all, we will differentiate this term. Here constant and variable both are together. Constant will keep out, differentiate variable. This power will come down, minus 1 from original power. It will become equal to 12x cube. Now we differentiate second term. this constant will keep out, this power will come down, minus 1 from original power, it will become equal to 4x. Now we differentiate this third term, x to the power is 1, this power will come down, minus 1 from original power, it will become equal to this one and minus 5. This is a constant. We have already discussed differentiation of a constant is always equal to 0. So we will put this one here and this one here and this one here and this one also here. So this will be called our final answer. Here you can see when y is connected with the so many terms, then we separately differentiate each term and apply given a sign. Now we will see product rule of differentiation. Y equal to u into v. First of all, we keep u as it is, differentiate v with respect to x, then apply plus sign, then keep v as it is and differentiate u with respect to x. Only in the case of product rule, initially you can keep v as it is and differentiate u. After that, you can keep u as it is and differentiate v. Only in the case of product rule. So, here this is our given equation. Suppose this is u and this is v. First of all, we will keep u as it is and differentiate v with respect to x. This one is v. Then apply plus sign. Then keep v as it is and differentiate u with respect to x. So, we will keep u as it is and differentiate v with respect to x. This power will come below and we will minus 1 from original power. It will become equal to 3x square. Minus sign and differentiation of x is equal to 1. So, it will become equal to minus 3. Then apply plus sign. We will keep v as it is and differentiate u with respect to x. This power will come below and minus 1 from original power, it will become equal to 2x and differentiation of constant is equal to 0. Then we will solve this. It will become equal to 3x to the power 4 minus 3x square plus 3x square minus 3 this one. Then apply plus sign. Then we multiply, it will become equal to 2x to the power 4 minus 3x square. When we solve this, this will be cancelled out. When we solve 3x to the power 4, 2x to the power 4, it will become equal to 5x to the power 4 minus 6x square and minus 3. This will be called our final answer according to product rule. Now we'll see division rule. Given u by v, because we are talking about division rule. So in such a case, first of all v, which is a denominator, we will keep as it is and differentiate u with respect to x. Then apply minus sign. Then keep u as it is and differentiate v with respect to x and divided by v square, that means divided by square of denominator. We will clearly understand with the help of one example. This is our given question. This is u and this is v. First of all, we will keep v as it is and differentiate u with respect to x. Differentiation of x square is equal to 2x. Then apply minus sign and keep u as it is and differentiate v with respect to x. Differentiation of x plus 1 is equal to 1 and divided by v square, that means divided by square of x plus 1. So we will solve this 2x square plus 2x minus x square divided by square of x plus 1. So when we solve this, it will become equal to x square plus 2x divided by square of x plus 1, and this will be called our final answer according to division rule. Now we will see applications of derivatives in economics. If total cost function is given, we have to calculate marginal cost, then we will do differentiation of total cost function with respect to quantities. That means derivative of total cost function with respect to quantities will be called marginal cost. Similar, derivative of total revenue with respect to quantities will be called marginal revenue. Derivative of total profit with respect to quantity will be called marginal profit. Derivative of total utility function with respect to quantities will be called marginal utility. Derivative of consumption function will be called marginal propensity to consume, and derivative of total product will be called marginal product. Now we will solve one problem. Total cost function is given. We have to calculate marginal cost. In order to calculate marginal cost, we differentiate this total cost function with respect to quantities. Derivative of constant is 0. Derivative of here in place of x we have q. Derivative of 15q is equal to 15, and derivative of 0.3q square is equal to 0.6q. So this will be called our marginal cost. Value of q is given. Value of q is equal to 40. So in place of q we will put 40. So when we solve it, we become equal to 39. So marginal cost at 40 quantities is equal to 39. So when we differentiate total cost function with respect to quantities, it will become equal to marginal cost. Now we will see next application of derivative in economics. We apply concept of derivative to find out elasticity of demand, because derivative explain the rate at which demand change due to change in income, price and price of related goods. This is our given demand function. We have to find out income elasticity of demand. Here P price which is equal to 2, I income which is equal to 10. First of all, we will calculate value of Q by putting P equal to 2 and 10 equal to I. When we solve, it will become equal to 36. That means value of quantities is equal to 36. This is our formula to calculate income elasticity of demand, dq over di. That means we have to differentiate with respect to I, with respect to income, because we are finding income elasticity of demand. I original income, q original demand. So when we differentiate this function with respect to I, it will become equal to 3, because derivative of constant is 0. There is no I, we have to differentiate with respect to I. There is no I, there is P. We are not going to differentiate with respect to P. That's why it will also become equal to 0. And when we differentiate this 3I, it will become equal to 3. So, differentiation with respect to I will become equal to 3. So, in place of dq over di, we will put 3. In place of I, we will put 10, because value of I is given. In place of q, we will put 36. When we solve, it will become equal to 0.8. 0.8 will be called income elasticity of demand. Next application of derivative in economics. We apply derivative to solve optimization problem. Here we have one example of optimization problem. This is our given profit function. We have to find out output where our profit is maximum. In order to find this, we differentiate this function with respect to q. Derivative of q square is equal to minus 2q. Derivative of 50q is equal to 50. From this value, we will find out value of q, which is equal to 25. In order to ensure our profit is maximum at this output, at this quantities, we will take a second derivative test. If second derivative test is in negative, that means this quantity is giving us a maximum profit. So this is our first differentiation. We will do differentiation again. It will be called second derivative test. When we do differentiation again, this become equal to 0 and minus 2q become equal to minus 2. So here you can see our second derivative test is in negative. That means this 25 quantities is giving us maximum profit. Now we'll see some questions. Find out derivative of this function. First of all, this power will come down and we will minus original power with 1. It will become equal to 3x square, and the derivative of x is 1, so it will become equal to 3, and the derivative of constant is 0. So this will be our final answer. Our right option is A. Given a total cost function, what is marginal cost? In order to find out marginal cost, we differentiate total cost function with respect to quantity. So, derivative of x square is 2x, and derivative of 10x is 10, derivative of constant is 0. So right option is A. A is marginal cost. Given consumption function, what is marginal propensity to consume? First derivative of consumption function with respect to income will be called marginal prosperity to consume. First derivative of consumption function with respect to income will be called marginal propensity to consume. C consumption, Y income, 100 is autonomous consumption. We have to find out marginal propensity to consume. So we will differentiate consumption function with respect to income. So derivative of 100 is 0 and derivative of 0.8x is equal to 0.8. So our right answer is 0.8. 0.8 will be called marginal propensity to consume. This is given demand function, this is given price. We have to find out price elasticity of demand. Which one is price elasticity of demand? This is formula to calculate price elasticity of demand, dq over dp. That means we have to differentiate q with respect to p. P initial price, Q initial quantity. First of all, we differentiate this demand function with respect to P. Derivative of 300 is 0. Derivative of minus 5P is equal to minus 5. So, value of dq over dp is equal to minus 5. P is given equal to 40. In order to find q, we will put p equal to 40. When we put p equal to 40, q become equal to 100. So, value of q is 100. When we solve, it will become equal to minus 2. So, our right option is C. This is all about today's video. I think you got it and thank you so much for watching this video. Bye. Take care.